Hello everyone and welcome to the sky this month for June 2023. My name's Paul Martinaitis and this show is brought to you by the Astronomical Society of South Australia. So it's certainly getting quite cool here in the evenings in Adelaide, but it's well worthwhile getting out. Of course, when the clouds happen to clear, there's some wonderful sights to look at. This month we're going to concentrate on the constellation of Centaurus, which is very, very well placed now, high in the southern sky. And then also starting to come up fairly high now are, of course, the great winter constellations of Scorpius and Sagittarius. So we'll talk a little bit about some of the objects in those constellations in this show. And then in the July show, we'll look at those constellations in some more detail and some of the hundreds of objects that are available there to look at. So without further ado, let's take a look at the sky for June. So the sky shown here is on the 20th of June during the dark sky period when the moon won't be interfering, and the time is 9 p.m. in the evening. So we're looking at to the west, in the west now. So this is the part of the sky which will be setting first. And we can see there right in the middle is Hydra, sort of going vertically. So Hydra, of course, is the longest constellation. And you can see it's so long that part of it's down below the western horizon, and it can snake all the way up and reach past the zenith. So that gives you an idea of how long Hydra is. So even though part of it, of course, is below the horizon, don't forget that M83, an object we've talked about a number of times before, is really, really well placed near the zenith. So the views of M83 are really as good as they get. So please, if you get to a dark sky and you've got a telescope, make sure you take a look at that galaxy. And while you're at it, of course, don't forget a favourite of many, the Ghost of Jupiter planetary nebula in Hydra as well. Still reasonably well placed for looking at as well. So moving a bit along now to the northern sky. So at this time of year, Leo is now starting to set fairly early in the evening. So really your last chance to look at things like the Leo triplet, for example. But the Macarian's chain and all the galaxies in Virgo and Coma Berenices are still reasonably well placed for observation. So in last week's show, we took a detailed look at Coma Berenices, and we looked at M64, the Black Eye galaxy. We also looked at a couple of the globulars in Coma Berenices as well, and some other galaxies. So if you missed the May show, you might wish to just go back and review the section on Coma Berenices, because it's still a good time to look at some of the many objects in that constellation. Looking in a more northerly direction now, we can see that Hercules is now coming above the horizon. So Hercules is always reminds you of a little bit of a mini version of Orion. It's one of the other constellations that actually does look like a stick figure of a person. So if you've got a nice unobscured northern horizon, see if you can spot Hercules. It's quite distinctive. You'll know it when you see it. And take a look for the globular cluster M13. So in the Northern Hemisphere, people often regard that as the finest globular in the sky, certainly the skies that they've generally got access to. And indeed, it is a fine globular cluster. So if you've got a good view of it, be sure to take a look. It's one of the best times of the year to look at it, because it never really rises very high for us from our vantage point. But of course, here in the Southern Hemisphere, we're very lucky because we actually have 3 globular clusters that are even better. We have the Parvo cluster, we have 47 Tuc, and of course the largest of them all, Omega Centauri, which we'll talk about in today's show. Looking to the east now, and we can see that the great winter constellations are now really starting to rise. So towards the left here we have Ophiuchus in the middle there, surrounded by the serpent. So Serpens is actually unique amongst all the constellations in that it's split into two parts. So we have Serpens cauda, which is the tail of the serpent, and Serpens caput, which represents the head, and that's each side of Ophiuchus, which is in the middle there. So moving a bit towards the right, we then, of course, have Sagittarius there with its very, very distinctive sort of double triangle shape. And then further up, we have Scorpius snaking its way across the sky. So sometimes we refer to, April and May as galaxy season because you have all those wonderful galaxies that we just saw before in near Virgo, Leo, and Coma Berenices. So really, as we come into this time of year and into winter, sometimes I sort of think of this as globular season. So now we're actually looking, as we look towards Sagittarius and Scorpius, we're actually looking at the center of the galaxy. So that glow that you see in the background there, that's the central bulge where the center of our galaxy is. And so this is also where the globular clusters tend to be more visible because those globular clusters, of course, are in spherical orbits about the Milky Way. So there's many, probably almost 100 of them that you can view in this part of the sky. And so all of these yellow dots represent just some of the brightest ones that you have access to. So a lot of them are very easy to find. In particular, for example, if we zoom in a little bit into Sagittarius, because they're all amongst this very distinctive shape, they're quite easy to navigate to. So, for example, if you go to the tip of this triangle here, which is Gamma Sagittarius, M28 is only about 1 degree away. So it should really be visible in your finder. And so that's sort of a fairly compact, still relatively bright globular cluster. And then if we go back to Gamma and then move down a bit, there we have M22, which is a very, very bright and prominent globular cluster. And there's many others as well. So, for example, you have M54 over here, which is also, fairly close to that star Zeta. And we have M69, amongst others. And before we mentioned, when we're talking about M13, we mentioned Parvo, the great Parvo globular. So we'll just take a look to the south. So there's Parvo, and there is the Parvo globular, 6752, also known as Caldwell 93. That's probably the third best globular in the sky, in my opinion. So you can have a look at that. Down below there is 47 Tuc near the small Magellanic Cloud. Doesn't look very good in this simulated image. Looks much, much better through the eyepiece. Regarded by many as the best and the finest of all globular clusters in the sky. And if we look up a bit higher, we of course have Centaurus the Centaur. So that's now very well placed, and we have Omega Centauri, which we'll be looking at, focusing on a bit later in today's show. So let's now check out the calendar for June. So the nights are now, of course, nice and long, which is good for astronomy as we're heading towards the solstice on the 22nd. So at the beginning of June, darkness began at 1842 and went through to 5:46 in the morning. By the end of the month, a little bit past the solstice, the night's starting to get gradually just a touch longer again. So darkness will begin at 1844 and go through to 5:54 in the morning. So the dark sky period, where the moon won't interfere with our observations, that began on the 10th and will go right through to about the 21st of the month. And full moon was on the 4th of June. Last quarter was on the 11th. New moon will be on the 18th. And first quarter will be on the 26th. So let's now take a look at the solar system. So last month, May was an excellent opportunity to view Mercury, but you can see by the beginning of June, it was already starting to get closer to the Sun. And then as the month progresses, it'll quickly go into conjunction with the Sun. So really not a good month for looking at Mercury. However, Venus and Mars are still quite well placed. So in the evening sky, Mars and Venus will tend to appear quite close together in the sky. And indeed, by the time we come to the 22nd, there'll be a nice little grouping, a triangular grouping of Venus, Mars, and you can see the Moon there will also join in the fray. So that'll make quite a nice sight. Now, telescopically, of course, Venus, worth a look at that particular position. That'll show about, I think, about a half phase or maybe slightly less. Mars, unfortunately, the diameter of Mars is now around between 4 and 5 arc seconds. So it's really too small to bother looking at through a telescope, I think, at this point. We'll have to wait another couple of years until it comes to opposition again. Looking now into the evening skies and the outer planets, Saturn is rising, I think, at about 10:30 p.m. in the evening. So once you get into the hours after midnight, that'll start to rise quite high in the sky. Same with Neptune, and also it's got a diameter of around 17 arc seconds at the moment, and it's also quite bright as we're heading towards its opposition later in the year. So good opportunity to start looking at Saturn if you're up in the hours between midnight and dawn. Neptune also rises at about midnight, so still a good opportunity for viewing Neptune as well while you're out there. And finally, Jupiter rises at about 3 a.m. in the morning at the moment. So to catch Jupiter, it'll be still fairly close to the horizon in the pre-dawn hours. And the only other planet is Uranus, and that's not really well placed as that's heading very near the Sun at the moment. So as we saw before, Venus and Mars will be quite close together throughout the month. So this shows you a view on the 15th of June in the evening around 6 p.m. And you can see there that Venus is right in the middle of the constellation of Cancer. And then you can see Mars just a little bit above it. And then as the month progresses, they will get a bit closer. And finally, on the 22nd, at around the same time, 6 p.m, after sunset, the two planets will be joined by a lovely crescent moon as well. So it makes quite a nice naked eye sight for you to look at while you're out there. And of course, if you happen to have your binoculars or even just a small telescope, take a look at Venus and you should see a nice little, I guess, slightly less than half crescent there. And of course, you also have the crescent moon as well too, which is always a lovely sight as well. Now let's take a look at the dawn skies and some of the outer planets. So this is early morning on the same day, on the 22nd of June. So this shows you around 5 a.m. So you can see there on the top red arrow, that's the position of Saturn, currently in Aquarius. So Saturn rose at about 10:30 in the evening. So by early morning, that's really, really high up in the sky. Nice opportunity to look at Saturn if you happen to be up at that time. Jupiter, on the other hand, much lower, down there near Cetus, between Cetus and Aries. That rose at 5 a.m. So doesn't really get a chance to rise very high at the moment before the sun rises. So this month, we're going to focus on the constellation of Centaurus. So that's really well placed, nice and high in the southern sky at the moment. And most of you would be familiar, at least with part of Centaurus, which of course are what we call the pointers, the two, some of the brightest stars in the sky, the two stars of Alpha Centauri and Beta Centauri. So they're called the pointers because, of course, they point towards the Southern Cross. So this actually represents the foot of the Centaur, or the front foot. So Alpha Centauri is sometimes called Rigel Kent or Rigel Kentaurus, the foot of the Centaur. So the constellation then actually continues from Rigel Kent up through, forms an arc of stars, and comes around to the hind leg. So it kind of surrounds the Southern Cross. It sort of curves in front of it. And the constellation also continues up to form the head and arms of the Centaur right up here in that direction towards Lupus and into Hydra as well. So our first object is going to be a double star, and it's a double star I think most, if not all of you would be familiar with, and that's Alpha Centauri. So that's very easy to find. It's the brightest of the pointers, and it's also an interesting double star because it's actually a triple star, and these stars happen to be the closest to our own star, the Sun, at about 4 light years away. So that just shows you a picture of the two brightest ones. So when you look at these stars through the eyepiece, they're well separated. The primary star actually has a magnitude of pretty much 0. So if you ever want to know what a magnitude 0 star looks like, that's pretty much what the primary component brightness is. And the secondary component is a little bit dimmer at 1.3. And they're separated by about 7.8 arc seconds. So quite an easy split in any sort of telescope, and they'll look sort of like a nice sort of bluish, whitish color. Now it is actually a triple system, so there is a third component that is quite a way away, and that's called Proxima Centauri. The reason it's called Proxima is technically that is actually the closest star to the Sun, so it's a little bit closer by I think about 0.1 light year to the A and B components that you can see here in the photograph. Proxima, however, is fairly hard to find, only because it's magnitude 11. So that's fairly dim, but still, quite viewable in, let's say, an 8-inch telescope or above. But the other problem is it's a little bit over 2 degrees away from the A and B components from our point of view. So you won't actually generally get them in the same field of view. So the main trick with finding Proxima is actually knowing which star to look at. So the best thing to do would be to either use a detailed finder chart, or you could use an application such as Sky Safari or Deep Sky Planner to find it. So while we're in this part of the sky, I thought we might as well just divert across the border into Caecinus, and there's another quite nice double star right at the tip, Alpha Caecinus. So Caecinus is quite a small constellation, just representing a set of dividers. So you sort of got the 2 points of the dividers there, and that's sort of the handle or the hinge of the dividers. And this is again another very easy double. So it's always nice to take a look at Alpha Centauri, and then you can take a look at Alpha Caecinus. So Alpha Caecinus, quite a bit dimmer than Alpha Centauri. So the primary is magnitude 3.2, secondary 8.5, but they do have a wide separation. In fact, wider than Alpha Centauri. The separation is 15 arc seconds. So you'll see quite a nice whitish primary, yellowish primary, and then a considerably dimmer reddish secondary. So they make quite a nice color contrast. And this pair of stars is also relatively close to us at 54 light years. So having looked at those double stars, we'll now just take a look at a few deep sky objects in Centaurus. So we're back at Alpha Centauri. We'll go to Beta Centauri, and we're just going to follow that arc up to that first bright star along that arc, Epsilon. And our first target is the globular cluster. We're just going to go up a little bit, NGC 5286. So that's quite a nice compact globular cluster, also known as Caldwell 84. And it also has a distinguishing feature that it has a lovely red star in the same field of view. So it makes a really nice contrast seeing the relatively compact globular cluster and that red star in the same telescopic field. So this globular cluster, you can see there that its brightest star is magnitude 13.5. So what that means is the brightest stars in that globular cluster are around 13.5. And then, of course, the rest, a lot of them are much dimmer. So that means in a reasonable sized telescope, you will be able to resolve some of those stars against a sort of a granular background.
Um, so like many objects in the Southern Hemisphere, this was discovered by James Dunlop in Brisbane, Australia, in 1827. Now, all globular clusters, of course, contain old stars, but 5286 is believed to be one of the oldest globular clusters, and its estimated age is around 12.5 billion years. So you can compare that to the age of the universe, which is around, let's say, 13.5 billion years old. So that's a first stop, NGC 5286. And what we're going to do now is we're going to move along to probably the most famous, one of the most famous globular clusters, Omega Centauri. So that's actually been known as an object, I guess, since antiquity. It was just seen as a star because you can actually see it with the naked eye on a very dark sky, and certainly you'll see it in a pair of binoculars. But it was first recognised as a cluster, in other words, recognised for what it was, by Edmund Halley in 1677. The same person, of course, who discovered or who first predicted Halley's comet's return. So this is the largest of all known globular clusters, probably believed to be the core of a devoured of some dwarf galaxy that the Milky Way has cannibalized in the distant past. And you can see there, much brighter than the previous globular cluster, integrated magnitude of 3.5, and its brightest star is 11.5. So that means many more of the stars are able to be resolved. So on a good night with tight seeing, through really any sort of telescope, you're going to resolve some of those stars. And the more aperture you have, the more of those stars you're going to be able to resolve. And I really like this picture here because this kind of represents really what you can actually see through the eyepiece, certainly through, say, a 12-inch scope under a dark sky. You can almost see that many stars in the field, and they also have this lovely golden color that you can see there in that photograph. Many astronomical objects, of course, appear grey to us, including some of the dimmer globulars, but Omega Centauri really has that golden yellowish hue to it as well, which just simply adds to its magnificence. The other thing to note is take a look at the apparent diameter there. So that's 36 arc minutes. So remembering about 30 arc minutes is half a degree, which is the size of the full moon. So Omega Centauri is actually a little bit bigger than the full moon. And you'll really appreciate that if you look for it in binoculars. So if you just take your binoculars, start at Epsilon Centauri there, and just sweep your binocular across in that direction, and you'll know it when you see it. It'll be this really compact, fuzzy ball, and it looks huge in the sky. It's unbelievably huge when you see it through binoculars. So we'll now move on to our final object, which is NGC 5128. So you can locate that. So you can see there I've kind of been following sort of a straight line from 5286, 5139, and there we have 5128. And this is also known sometimes as the Hamburger Galaxy, or Centaurus A. So this was also discovered by James Dunlop a little bit earlier in 1826. Quite a close galaxy by galactic standards at 13 million light years away. And it has the distinction of having the most prominent of all dark lanes in any galaxy that we look at. So you might remember last month we looked at M64, or the Black Eye Galaxy. That also has a fairly prominent dark lane. And many of you would also be familiar with, I think it's M101, or M110, which is the Sombrero Galaxy, which also has a very prominent dark lane. But Centaurus A has the most prominent of all. So this sketch on the top right here, I kind of like this sketch because that shows you what the galaxy looks like under, say, a suburban sky, where you've got a reasonable amount of light pollution. But even so, you should still be able to perceive the galaxy fairly bright, so you should still be able to see the halo, and you'll kind of see a darker region cutting through it. And that really, you can see there from that sketch, why some people call it the hamburger galaxy. The photo to the bottom left, though, that really shows you some of the detail that you're capable of seeing under a truly dark sky and a larger telescope. So through, say, my 12-inch, for example, I can see that round halo there, and I can start to see, you can see in the photograph there, those jagged edges. So you can actually see those wispy jagged edges in the telescope, and you can also see that division in the lane that you can see there through the middle. And you might also notice that the halo has some of these little black holes there. So they're also visible on a night of excellent seeing and transparency as well. So this is a really great galaxy, and it's one of the few galaxies that has something to offer under a relatively light polluted sky, but it also has so much more to offer under a dark sky as well. Thanks everyone for joining me in today's show. It's been my great pleasure in presenting it to you. I hope you found the information useful, and let's hope there's some nice cloud-free skies so you can get out and observe some of the wonderful objects that are available. And so until then, stay warm, get some good viewing in, and I will see you in July's show. Bye for now.